How about the O2 wide open throttle test? Questions on that? I was thinking of the plugged exhaust. I've recently done a case study on a restricted exhaust system, and I really wish I would have had the opportunity to look at the fuel trim numbers a little bit closer. It was last term that we looked at it, and it was the same day, literally, when he drove home, he got into an accident and totaled the truck. So like the opportunity for me to do further testing on that Ranger is gone. That sucks. I was just thinking about that. It's a little off subject, but let's talk about it for a minute because we're talking about restricted exhaust testing here. And actually, I have this further in this chapter. Let's go down to it. We're going to skip ahead for a second. Page. Exhaust backpressure testing, page 28. Let's jump down to this. Using a pressure gauge. Should be less than 2 psi at 3,000 RPM. You want to remember that number. That's a test question. I'll show you these videos here in a second, but I want to talk about the trim and see if I can plug in some fuel trim numbers on plug exhaust. I don't think it's one of those tests that will say definitely restricted exhaust. See, when I do troubleshooting, I like tests that don't have variables. This would be one. If I put a gauge into, say, the O2 sensor hole and I measure back pressure and I have, X amount of pressure in there, I know for a fact that I have a restricted exhaust. There's no other variable that would cause 8 pounds of back pressure, say at 2,000 or 3,000 RPM, steady throttle. I know there's no other variable to that. Now, this fuel trim one I want to cover with you, I believe there are variables to it, and we use it as a guide. You see the difference? So we have a test that we use as a guide to maybe put us in that direction, or we have a test that says it is definitely that problem. And so I like the ones that are definitely better than I like the ones that would be a guide. However, the guide's important to get us there, so it's worth talking about. The Ford that we just worked on, it was a V6. It was a goofy design. I've never really paid too much attention to, or I've never seen one like this. It had a cat here. These are the exhaust manifolds I'm drawing. It had a cat here, and then it had a Y pipe that connected the two. It had another cat, and yet another cat. So there were 4 cats on this Ranger. Ultimately, all it was this one was restricted. Okay? And I can show you the test that we did on that here in a minute. That cat was restricted. So I had some of my premium subscribers. This is really where we were debating this, is on that channel, and we were talking about other ways to identify. And I wish I could mention the names right now. I don't remember their usernames and give them credit. They were telling me about using fuel trim and identifying that. Could we have used fuel trim and looked at those cats, or as a guide to which cat was plugged? And so the theory is this is a mass airflow engine. So my intake would sit here. You'd have your throttle plate here, throttle body, and then the mass airflow would sit out here. So remember that all the air that's coming into this engine is going to go through that mass airflow sensor. If we have one side that's completely restricted, can you picture this airflow really primarily going this direction, say more so than on the restricted side?
Yeah.
Just from a flow standpoint. All right. So the theory would be, with this mass airflow, so would it be less or more? I'm trying to think of which one would be negative, which one would be positive. We would be lacking airflow on this side. See, I don't know if I can do this or not. Let me me see if let me read the post and see what he said, and let me see if I can plug it in. And then I'll get his name too. Okay, so the comment, I was incorrect, was on this is on my free channel. I did 2 videos. I did one on my free channel, which is this one, how to test for a plugged exhaust. And then what we did for the premium one was we, sat in class, we talked about it, kind of interviewed Mr. Kaplan as far as direction, where we were going. Anyway, that's where I got this comment. This, I don't even know how to pronounce this guy's name, but let's give him credit for it. Yeah, he says, Paul, if the fuel trims are normal, then the plugged cat is the rear one. Okay, that's pretty decent. That means airflow to both. I get what he's saying there. This is because the MAF correctly measures the incoming air, then the air is equally distributed bank to bank. If the fuel trims are negative on one bank and positive on the other bank the same amount, example, negative 22 total fuel trim on bank 1 and 22 positive fuel trim on bank 2, you guys following? Then only one bank is plugged. This is because the engine's now drawing in less air due to one of the bank's cats being plugged. The MAF reads the incoming air correctly, let's keep that in mind. But then the unrestricted bank takes the majority of the air and the restricted side does not, but the fuel is still being added by the injectors on the restricted side. This makes total sense to me. This means the restricted side is getting too much fuel for the amount of air it has available. So what's that side going to do, guys? It's going to go rich, isn't it? The side with the plugged cat. You guys follow what he's saying? Airflow into the engine being properly measured by the mass airflow sensor. So remember that with that mass airflow, that all the injectors are going to get the same amount of fuel initially from that fuel map, right? That mass airflow is telling us where on the map we should be. Both sides would be initially, before fuel control and closed loop comes in, and O2s initially would be getting the same fuel. But the air would not be there on the plugged cat side. That's what he's saying. So what's that bank going to do? Once the O2 comes into play, what's that bank going to do? It'll go negative, rich condition, right? And then what's the other side going to do?
Positive.
Will it be positive, and why? There'll be more airflow on that side, huh? That makes sense. All right, this means the restricted side is getting too much fuel for the amount of air it has available, and this means the side with the negative fuel trims is the restricted. Hope this helps. Thanks. It absolutely helps. I told him, great tip, thank you. And look, I'm actually upset. I wrote that I didn't do this test, and I told the student, I said, get this thing back to me, please, and I want to do this test and see what it looks like. I'm not sure. See, I like what he's saying here with the same amount. This might be key in using this. If the negatives and positives are the same amount, because I've seen other things that will cause that. For example, a timing chain that's one tooth off on one bank. Think of a dual overhead cam engine where the chain's off a tooth. I have seen this kind of situation where you could have negative trims on one and positive on the other. I've seen reversed O2 sensors that can cause that. So you guys with me on this test not being a absolute conclusive, here's our plugged system, but can we use this as a guide? And the whole debate for me in this process was in figuring out, let's put our setup back up here, in trying to figure out which cat was plugged. Right, 4 cats. I mean, if it's your vehicle, don't you want to know which one's plugged, or do you need to change them all? Or right in the field, I mean, in the past we've done them all. Ultimately, what I did is I ended up drilling holes here. I did one here too, and then I did them upstream. So I did 5 different measurements, mostly for the video, just to prove that what we did, that we picked the right direction, because I was developing a new way to see a back pressure problem. And I don't have this stuff in my book. Maybe we'll write some stuff down, and I'll show you guys the waveforms. We could probably do that together. But it was only this cat. So in his example, this side would have been negative 22, right? Just numbers he picked. And this side would have been positive 22. I'm not so sure about the evenness of this. I would definitely like to see it. You know, I have the scan data capture. Hang on a second. All right. Unfortunately, I cannot open that file right now. I'll work with my ShopStream program and find out why that's not opening later, and maybe we can revisit this. But I wanted you guys to be aware of that for back pressure testing. That would be a note here. And I think that what we need to be careful of is this wouldn't be for everything. It would have to be dual exhausts. It would have to have dual cats for us to even debate this. Does that make sense?
28.
We can't use fuel trim, I think, as a blanket statement on all cars, on all systems, to do a back pressure test and find a plug exhaust. Can we look at our trim numbers on a vehicle that has bank controlled or two different cats, two different banks? I think it would be useful to look at. So I don't know, help me develop that note here. What do we want to put in here? For, let's see, this ink's gonna fight me, isn't it? Yep. Right here. Let's say for dual. How do I spell dual? What is it?
DUA.
Yeah, that's what I thought. For dual exhaust. And to be honest, that Ranger wasn't dual exhaust. It was dual cats. So maybe dual cats would be a better, I don't know, for dual exhaust. Or maybe in parentheses, two separate, that's another hard word to spell. How do I spell separate?
ATE.
I get it wrong every time I spell it. S-E-P. A-R?
Yeah. ATE.
Is that right? I suck at spelling. I'm sorry. Two separate, I want to say upstream. Let's say that. Upstream cats. Two separate upstream cats. That's that Ford Ranger video, right? Ford. I'm going to write Ford Ranger. You guys can look up that video. Let's say, watch your fuel trim numbers. Trim numbers as a guide. You guys with me on the guide? As a guide. Right? If we have opposite trim numbers, we may have a restriction in that exhaust system. Watch fuel trim numbers as a guide. What are we looking for? Look for opposite trim numbers. But here's the catch for that. Our trim numbers are only going to be opposite if it's one of the upstream cats that are plugged. If it is a downstream cat, you're not going to have opposite trim numbers. You guys follow what I'm saying? They'll be normal.
Would it still be back pressure?
We'll be back to regular back pressure testing. In fact, I would still suggest that we do regular back pressure testing to confirm it, but we're going to use some scan data as a guide. I like it. I've told you guys this yesterday too. As much time that I can spend in the driver's seat looking at scan data and analyzing will cut down my testing time once I get out of that driver's seat. And that's why I'm writing this down. I think it's completely valid and it's worth looking at. When I open up, hopefully I'll be able to open up that file because I do have some scan data captures from that Ford Ranger, and I'm hoping to see this effect here. I don't know if I'll have it or not, but we'll try. For dual exhaust, two separate upstream cats, watch your fuel trim numbers as a guide. Look for opposite trim numbers. And what would that suggest? If we saw that, would suggest one
Upstream.
upstream,
Cloud.
upstream restriction. One cat, one upstream cat. I don't like the way that's worded, but you got it anyway. Need more room to write. Look for opposite trim numbers. I don't like that, because you're gonna read that down the road and be like, what did I write? You need to be able to refer to this later when you're in the field. Look for opposite trim numbers. I don't know how to shorten that or word that or notate that right now. I think we talked about it enough. You guys are going to have to do that on your own. I'll just talk about it one more time. Look for opposite trim numbers. If you see opposite trim numbers, and this subscriber suggests that they're going to be the same amount. I'm not sure if that's always going to be the case, but if you see opposite trim numbers, then that suggests one of the upstream cats. Okay? If we see normal fuel trim numbers or ones that are not opposite, that doesn't mean we don't have a plugged exhaust. That means that if it is plugged, it's not one of the individual upstreams, or it could be both upstreams that are melted down and restricted the same amount. So there's lots of variables here. Again, this is a guide. I think it's worth using. All right. We good with that? You guys think you can notate that in your book somehow? Like, think about it like this. 6 months from now, you're going to refer back to this and be like, wait, what was that? You're going to have a car. You're like, there's another task to do. Are your notes good enough? Look at it from that perspective, that 6 months from now, you look at that page and you're going to be like, okay, I remember. Well, the other thing you could do is, this is all being recorded, so you can just listen to it again. That's the bonus of what I'm doing here. So, okay, so as a guide, we got that, right? So our guide is there. So next step then is our absolute ones, which are back pressure tests. Our back pressure testing involves putting a gauge into the exhaust and holding the engine at 3,000 RPM. The 3,000 RPM number is no loads in park. So what you guys need to understand is the throttle plate is barely open on a normal running engine to hit 3,000 RPM. In park, you're just cracking the throttle plate. It doesn't take much. So it's not a lot of airflow into the engine, which means that we shouldn't have a lot of back pressure coming out, correct? There'll be times when you drive a car under load, if you're at 3,000 RPM under load, half or full throttle, you're going to have back pressure in the exhaust. It's designed that way. But that's not when we're measuring it. We're measuring it no loads in park, and it should be 0 PSI. So let me show you just a piece of this where I did the test. We'll skip past. This is on the premium channel. We're debating some waveforms, and I'll come back to that maybe later. I just want to show you the back pressure testing. And guys, this is the first time that I drilled holes in an exhaust system to do this. I normally will pull the O2s out to do it because I don't want to change the characteristic of the exhaust system. But honestly, after drilling these holes, I was comfortable with maybe doing this in the future because it was way easier than pulling out a rusty O2 that you might damage in the process. And we just tack welded them back up when we were finished. So I drilled holes primarily for trying to figure out exactly which cat was restricted. Does that make sense? It's the same procedure, even though in my text here I'm saying remove the O2 or go at the pressure transducer or EGR pressure sensor. Another way is to drill a hole. I mean, that's okay too. I'm all right with drilling a hole. And so I'm just using a little rubber plug here. Hang on a second. I don't know how well that resolution's showing up. It's crap. 240. Let's go, bigger screen. Pretty tough to see that part on this snow capture. And I'm just holding a rubber plug over the hole. And am I running it now? 1,000. Yes, I'm yelling. So yes. That, do you see it barely climb off 0?
Barely.
All right, so the test I did for that one, if you can see where I'm at, I have a cat right here, kind of tough to see in this still image, and there's a cat here. These are the 2 downstream ones. I'm not into that Y pipe yet, right? I'm not upstream. I'm just showing that basically with this test, so the hole is right here, with this test being 0 PSI at this point. What's that tell me about this cat? That's really what I'm going after here. How is that downstream cat with that test? It's good. That's what we want. Remember, the exhaust is coming down this way, right? So if I'm 0 here, how is this cat? That cat's good.
Yeah.
Okay? So then I did another one upstream, which is coming up next. That's a little better. I should have paused it right there, and you can see those cats a little better, right? You guys with me on the design? You see where I drilled the hole? Okay? Again, we're trying to save this customer money. We're trying to save ourselves money. If it's our car, we're, trying to be accurate. The next part right here.
Is it the Y?
Yes, this is the Y pipe. So what we have is the cat here. This would be my driver's side, and this is my passenger side. And the reason I did 2 holes here and here instead of like 1 is I wasn't sure how far into the cat that these pipes went. Does that make sense? Mm-hmm. I didn't know where they were tied internally and how they were tied. So rather than, and I couldn't really drill in this area. So really these 2 tests are just the same test. What am I trying to accomplish with this one? I'm trying to see if that cat is a problem. Okay? That's why I'm there. So the result of this will tell me where I'm going. Now, I mentioned before, too, that I didn't need to drill that back hole. I could have started here because, as you're going to see, when I measure these 2, they're both 0. These are both going to be 0. So if you read zeros here, do you guys understand that there would be no reason to come down here and drill a hole? Why did I do it in the video? Well, I knew I had a plugged cat and I was just tapping into everywhere I needed to be to prepare for the video. So that was really why I drilled the extra holes. It wasn't really filming that part, thinking about that. I didn't need to do that downstream one, but that's okay. If we had pressure on these guys, you guys understand then we would have to know if it's this cat or if it's the downstream you can't see in the picture. Now I have to drill between them to see where that pressure is. That's what I'm doing. Okay? All right, so the next part, question? Okay. All right, let's see where we're at. I think I show these 2. So I'm just holding that rubber plug over top of that hole, and then I check it at idle, and then I do it at 3,000 RPM, and you'll see that gauge move just a little bit. Gives you a little bit of perspective. Guys, this is what a good one should look like. Did I do it already, or?
Yeah, nothing moved really.
So yeah, I'm talking about that cat not being a restriction, and then I measure the other one. So it helps to see a good and a bad one, don't you think? When you're developing a test that says no more than 2 PSI, 3,000 RPM in park, do you see what a good one looked like? It barely moved at all, right? So that's what we want to see. In general, 0 PSI, and I'm giving you a spec no more than 2. To be honest with you, if I even approach 2, I'm a little bit concerned for this test. So why am I concerned? Because I've done hundreds of them that are at 0. So it helps to see good ones. And now I'm talking about not having to drill that. And now what I'm doing, guys, we missed the other test. I want you to see a good one. It helps to see a good one. Let me let that play for a second. Okay, I just kind of jumped over. Hold it. Didn't even move.
Yeah, it's.
I'll let you hear the sound for that. Hold on. What do you guys think? Maybe half a psi, if that.
Not even.
Not even, huh? Yeah. It just moved off zero, just a hair, right? That's a good free-flowing exhaust system. All right, now comes the. Now comes the.
I need to drill this back hole. I should have started up.
All right, this is my upstream one. Watch. Do you see
The
that?
driver's side one.
Watch.
There's my idle number. Go ahead, 3,000.
You need a bigger gauge.
Yeah, it went all the way around, didn't it?
I think it's just gonna keep going too.
See if I can catch that again. Hold on.
It's like Scott's gas, you know.
Watch it.
Okay, go ahead, start it.
Watch. Do you see just on startup we hit like, I don't know what that number is over there. That's like 4 or 5. That's like 6 psi right there.
There's my idle number. Go ahead, 3,000.
And that initially went all the way around, didn't it?
Yeah.
Who knows? 10, 11 psi maybe, something like that. There's 8 all the way over here on the right. And Matt, you mentioned doing a test. There's your $3,000. That was like 8 or 9 right there. You mentioned doing a test, and this is what Matt did for a plugged exhaust. Is he pulled the O2 out and then took it for a ride. You can hear how much exhaust gas was coming out of that hole compared to the other ones. That in itself tells you it's restricted. All right, so questions on exhaust back pressure testing. It's pretty straightforward, isn't it? And I have a few other videos where I'm doing back pressure testing. I can show you where, you know, I'm in the O2 hole. I have some other videos where I'm showing it in the pressure sensor for the EGR system. Would be worth at least showing you the image. I think the images are helpful.
Should rickroll somebody.
All right, this is the one I wanted to show you. The other ones. A visual is a good thing. This is the title of this video is testing for a plugged, clogged, I don't know, something, restricted exhaust converter. No wonder that one showed up on a Google search, because that one's got about every word you'd think of in there. But in this picture right here, what am I doing? I just removed the O2 sensor and I installed a gauge. It's no different than what I just showed you guys by drilling a hole. If it's an easily accessible oxygen sensor and it isn't rusted in there, then that's what we're going to do. I think from this point forward, after seeing how easily it is to drill a hole and then repair the hole when we're done, I think that's going to be my method of choice from this point forward as we live in the Rust Belt of Pennsylvania. And these O2s do not like to come out. And I have damaged oxygen sensors in the past just by removing them. Removing them and putting them back in, you know, you can kill an O2 if it's, I don't want to say on its way out. We talked about them. They don't really wear out, but there are sensitive components in there. And if it takes heat to get it out too, you got an issue maybe. So that's it. I'm just putting the gauge on there. I'll let you see what this one looks like. Guys, this is the one that we used for our low power. I showed you guys part of this, test drove it. This was yesterday, wide open throttle, O2 was at 800 millivolts, said what? O2 at 800 plus said our low power problem was not from a fuel delivery issue. Remember? And so we went toward a plugged exhaust because our O2 was rich the whole time we were at wide open throttle. All right, so I'll let you see the
Connected to where the O2
sound. And I just have I think it's the same gauge.
Looks like it.
A little out of calibration in that. Hang on, let me change this stream because this is 360 is not good enough for this. And actually, it was a little out of calibration there, and I tweaked the gauge in the next image here coming up. Yeah, this one is a little different. There's 15 psi on the right side of this gauge. The last gauge I was using was only 8 psi. And let you hear the engine.
Calibration on the gauge, no big deal. Go ahead and start the car. Okay, right off the bat, just simply at idle speed, we're already looking, what, about 2 PSI? What's that look like to you guys? 1.5 to 2, somewhere in that range? To have 1.5 PSI of back pressure at idle is horrible. We're already on the right track. We already know where we're going with this. Go ahead and hold the RPM up, 2,500 to 3,000. Hold it steady. So we got...
Right? 7 PSI. You guys understand the method I used on this Impala to find this restriction. Test drive, doesn't get out of its own way, O2 wide open throttle, told me I had enough fuel, it told me don't worry about fuel pressure, don't worry about a mass airflow problem. It feels like a plugged exhaust. It had sounds for a plugged exhaust. I could hear whistling under the hood. Once you start getting familiar with the sounds of a plugged exhaust, almost the symptom itself is enough. And then here's the proof. And there's only one cat on this engine, right? So, and I've had questions like, well, how do you know it's the cat? Well, what else is it going to be? It's the cat that melts down that causes the restriction. And someone inevitably somewhere has had a muffler come apart and one of the baffles broke and the muffler was a restriction. I've never seen that. Is it possible? For sure. I've had issues where I've had one of these and it was a welded exhaust system, and I worked for Pep Boys and we didn't have a welder back in the day, so we take Meineke worked, there was a garage right down the road. Any of our welded stuff, we'd send it down to Meineke and have them throw a cat on it, and then we'd bring it back and take care of the rest. Had a process done like that, told them to change the cat back. I said do all of it from the cat back. And the reason that I said that was I was concerned that pieces of that cat were lodged downstream in the muffler. That was how I wrote up the repair order. They brought it back to me and just put a cat on it. And it was one of those situations where it was like, hey, Danner, you blew the call. You know, that wasn't the right call. Look, we put a cat on it and it didn't fix it. I redid my back pressure test and I had the same result. Really high back pressure. So where did the piece of that old cat go? Into the muffler. These are things that you need to think about. So maybe drilling holes might be the answer for all of that. You know, if you have any question about where, if it's downstream behind the cat, then drill a hole and check it. So that's a location. Another one, guys.
So you said every time you replace a cat,
No,
you place the whole.
no. That's a good question, Ricky. Sorry. All right. You don't have to replace the entire exhaust system every time you change a cat, but you do need to warn the customer that if you're just changing a cat and it's a melted down cat, that there could be pieces of it downstream. There's two ways to handle that. One would be when you take the cat off, look at the downstream side, look in with a flashlight and make sure the honeycomb is intact. If it's intact in the back side, you're good. If you're missing pieces on the back side, you could be in trouble. They're further downstream. So that'd be one method. Another one could be that you could smack on the exhaust, listen for rattles. That's not ideal. The third one would be drill a hole. Do a back pressure test behind that cat, make sure you're good. And if you're good behind the cat, then you should be fine. If you're not good behind the cat, you still need the cat, but you're also going to need a muffler downstream. So that's, guys, again, there's two ways a cat can fail. A cat can fail for efficiency where you get a P420 code. P0420, which is an efficiency code, or P0430, which is an efficiency code. That doesn't mean the cat's melted down. It's just to the point where it doesn't do its oxygen storage anymore and it doesn't meet the OBD2 standard, and that's not a melted cat. It's a bad cat for efficiency. There's two ways cats can fail. And for an efficiency code, I'm never worried about downstream stuff. Just put a cat on it. That make sense?
Yeah, cause I brought a car in and she had the same efficiency.
The P0420. Did you ask me about it? And what I tell? Did I?
I
Okay.
guess I think it was busy, so
Okay.
I said somebody else, but they said, yeah, it's a bad cat.
Yeah.
So
That's a code. I have never seen the P0420 code not be anything other than a cat.
Yeah, it's really good.
And you know there's some debate. It could be the oxygen sensor and all. That's fine, and we could put that in there, but I've never seen it. Every single P0420 code I've had has been a cat. So, all right. So where did we attach the back pressure gauge on this one? Into the exhaust port. There's other ways to do it if you're familiar with your systems, and I have another video here. This one's titled exhaust back pressure testing, but I'm going to change that. Maybe I'll leave that title in there somewhere, but I need to make this better searchable. This was on some Fords, and the reason I chose Ford was they have this pressure sensor that you can adapt to for the EGR system. So that's really what I wanted to show you. This one is another area for an O2, and I'm sure this one's restricted too, and I'm showing that. I'm going to move forward here. Let you guys see. This is yet another GM with a restricted cat. So
1 and 2. 2 is.
There's my 8 PSI gauge I'm using again. This is the one we have in the tool room.
Oh, and we're gonna. At idle, we shouldn't have any. You're gonna notice.
Gift of gab I have. This is our idle number.
Just under a half. And I'm gonna hold it at roughly 3,000. I mean, I don't have a tachometer connected to this. Is there a tach on the dash? You wanna tell me when I'm at 3 grand? Just give me a no tach. Okay, well, just go by ear. We're gonna listen to the engine. That's probably about 2 grand there.
So not as bad as the other one, right? But is this bad?
Yeah.
Yes, it is. So in this video, I decided, well, I got a bad cat, and I'm going to show you some good ones too to make it just what we're doing here now. I got a bad one. Let's look at a couple good ones, see what they look like. And again, I'm in the O2 port for this one, and let's jump ahead here. Which one am I on? Oh, cool. This one was on a Honda or a Toyota. I'm right up front.
And we removed the O2 and installed our adapter where the
So I forget the car. You can watch the video on your own. But the point is, this is a good car. Let's look at a good one. This one had variable valve timing on it, if I remember. This one actually goes into a vacuum. Watch, it's kind of crazy.
stream O2, any back pressure whatsoever, which is normal to not have any at idle. Hold it at
Watch.
3,000 steady.
Watch. So that's a variable I haven't talked about before. Is that a problem? No, it's not a problem. What are we looking for? Pressure. I'm not concerned that there's actually a suction on the exhaust. Think about how well this engine's breathing if that back pressure is going down into a negative at that RPM. So that's pretty cool. I think that's a nice little variable to show you. It's not a problem. You don't have a plugged exhaust. If you see that, you're good. So keep going. Let's find another location where we're just trying to do easy back pressure tests. And hopefully this, let me let that play for a second.
Because I want to show.
Okay. In this picture, now this is unique to Ford, and these are things that we can look for though. Ford has a sensor, and it's right here. Kind of tough to see in this image. It has a hose here. It looks like a vacuum hose, and a hose here. And the sensor itself is sitting right here. Can you see it?
Kind of.
All right. That is called a DPFE sensor. And what Ford does with that sensor is they take, see if I can illustrate this. They take a tube that has a restriction in it, okay? And this would be exhaust gas coming in this side. So that tube's tied right into the exhaust system. And then they put the EGR up here. And then your intake side, this would be intake vacuum on this side. And they put these tubes, one would be here and the other would be here. So what are those tubes connected to? They're connected to the exhaust side of the EGR system. They're not vacuum hoses. They're exhaust hoses. Here's the point. Can I take one of those hoses, either one, unplug it, and just install my little cheap $10 vacuum pressure gauge on it and do a back pressure test. I mean, wasn't that easier than drilling a hole and easier than pulling the O2 out? We just go right to that sensor. It's not the only vehicle that uses things like that. In emissions class, maybe you guys learned about back pressure type transducers that they use for EGR systems. Chrysler had one, Nissan had one, I think Toyota back in the day. There was other places you can do this. What it would look like is it was a device that was kind of like this. There was an exhaust port here, a vacuum port here, and a vacuum port here. This would be intake vacuum here. The EGR valve would be on this side, and then this would be exhaust gas on the bottom. And what that exhaust gas would do is it would flex a diaphragm that would either open or close the vacuum through to the EGR valve. It was a control for the EGR system. This port that looks like a vacuum hose at the bottom is at another location. We can just pop that rubber hose off, install a cheap vacuum pressure gauge, and do a back pressure test. So I'm just giving you alternate locations. You guys can watch the video later. I wanted you to see that image, and that's what I'm describing here, guys. See if this makes sense now. Other locations, test locations, upstream O2 sensor, exhaust port, EGR back pressure transducers, the one I just described on Chrysler, Nissan, EGR pressure sensor on a Ford. We could add a couple more in there, right? What would they be? Yep, not gonna let me write in this program. We can drill holes, right? We can drill holes. And then one more is an in-cylinder pressure transducer. In-cylinder pressure transducer with a scope. In-cylinder pressure transducer with a scope. Do I want to do that now? No, you guys need a break first. Tell you what, I'll give you a break. Let me set up a couple of those, pull up a couple of those images where I'm showing this pressure transducer and show you another way, yet another way to do a back pressure test. The intro to this would be simply this. All you do is you take a spark plug out and you thread in a transducer, which is a device that takes a pressure and converts it to an electrical signal. So think about this. Taking a spark plug out, I'm putting a device in that I can measure electrical pressure and putting it on a scope, and I can see restricted exhaust there too. How cool is that on a system that, you know, the plugs are right there and you don't have to do anything intrusive at all? This is something new to me. I've only done it 2 or 3 times, and I've identified a plug exhaust. One was on this Ranger. It would be very, very good for you guys to watch both part 1 and part 2 of this Ford Ranger. That we were watching pieces of it, where we really use the in-cylinder pressure transducer to identify this restricted system. Part 1's on my free channel, part 2's on my premium channel. You guys, again, that are in here, you have access to that premium channel for free while you're in my class. Okay? I suggest you guys watch that. We'll talk a little bit about it when you guys come back from break.